Okay. The relation shape between the mathematical, actually, the mathematical, or we can call it statistical relationship between two or more, just two gauges. Gauges. This is also important. So two gauges assumed to have a good concordance if their correlation is at least linear. Actually, their linear correlation. Okay, linear correlation is at least at least 0.8 or 0.8 at least 0 point yeah 8, just like that. So how are we going just to do then further? Now there are a lot of estimators, isn't it? Bias. Okay, bias. We already just seen that one. This is bias means the difference in average of the two gauging system. Gauging system. This is okay. This is, we call it like bias. Okay, bias. Two gauging systems, actually systems. So this bias, we can call it like, let's say, gauge bias. Okay, gauge bias. Okay, gauge bias, just to make it clear in non-clear number. Suppose like this is one of the best way just to calculate the bias. Like when we define the gauge itself, let's say the point is just like this. So suppose I have two gauging system and I have some measurement. Okay, so gauge 1 and gauge 2. Okay, suppose x1, this is like y1, this is x1, and y2, this is x2, and so forth like that. Yn, this is xn. Okay, now what's gonna be the modeling? Okay, to do like gauge concordance, we need the modeling. Okay, model. So this model is, let's say, so this measurement is the measurement of y, and this is the measurement of like x, gauge x or whatever. So the model is, our assumption is y should be equal to x, isn't it? Y should equal to x. This is perfect agreement. So now, but this is not the reality. This is not the reality because y and x might just agree in certain percentage. Okay, certain percentage. So to make it more real, instead of writing x, I'm gonna write x beta. Okay, x beta like that. X beta is a proportion of x that matches with y. Okay, that matches with Y. So this is just Y. This is just reasonable model, but this is not always correct because there will be a bias usually. Because there is a bias, then this is equals to alpha plus beta x, and you see this model, this captures the bias, this captures the bias, match. And this is not always true because measurement itself has different factor. It's going to be like so this model is the best model to do concordance, okay? Gauge concordance, the study. So our expectation is, okay, our expectation or how much is going to be beta?
Why?
So this is the hypothesis. Okay. Or if it is containing 0, okay, contains let me write this like this. For alpha, if that contains that confidence interval, okay, contains 0, then bias is insignificant, okay, significant. Okay. Contains one, then the agreement is good. You see, the gauge agreement, the gauge agreement is good. Okay, good gauge agreement. So that is how you're gonna interpret for alpha and beta. Okay, for alpha and beta, and this is okay. ሚሊዮን የምትባል ሰውዬ እባክህ አትጮራቱ። አርሴናል ኳስ የሚያየው ነው አይደል የሚለው? So this is the estimator of bias, okay? This one is estimator of bias. Estimator of bias, okay? So just like that. So you're gonna just understand it. Now, the other comparison that we're gonna do is based on, categorical information. So now, assume samples. You have like samples. and based on specifications, okay, we categorize as, okay, we categorize as, okay, good or bad or pass fail, okay? Let's assume pass fail, okay? Pass fail, you see, fail, just like that. So now you're gonna think of this way. You're gonna think of this way. Let's say the measurement specification ranges. Now you have like the Y measurement, like Y1, Y2, okay, and so forth like that, YN, okay? Now what you're gonna do is just sort this one, sort this, sort that. When you sort that, you're gonna have like Y star, okay, 1, Y star, okay, 2, and so forth like that. Then Y star N, you see? Okay, you already sorted it. Now, specification, spec, your spec for those measurement, you see, lower boundary, lower specification limit, and upper specification limit. You got like, this is your spec. So now, assume you're here, that is your upper specification limit, okay? And you are here, somewhere here, that is your lower specification limit, you see? So that means if you are here, okay? If you are here, and those parts are passed, isn't it? Okay, those measurements from here to here are passed, but this one is failed, okay? Failed. This one is failed, and this one is failed. Am I correct or no?
Yeah, correct.
Yeah.
Okay, good. So now those measurements were like, you know, variable measurements, but we're gonna just categorize them as pass fail, just like that. Similarly, we're gonna sort the X measurement, okay, the X measurement. So this is, let's say X star 1, X star 2, and so forth like that, X star, okay, N, you see, just like that, N. So here, this is your boundary, this is your boundary. So right here, those parts are pass, isn't it? This pass for X, pass, and the other, this one failed, okay? This one failed. This one also just failed, just like that. You see, failed. So now let's put this information in matrix, okay? Let's put this in matrix. That matrix is called confusion matrix. But like any kind of, like, you're gonna give like any name, doesn't matter, but like they named it confusion matrix. So let's say why confusion matrix? Because ምንድነው ሴናሪዮ ገብቷቸዋል? It's like ሁለት ጌጂንግ ሲስተም አለ፣ ሁለት ጌጂንግ ሲስተም አለ። then አንደኛው ጌጂንግ ሲስተም ምን እያለ ነው? ኦኬ ፌል ያደረጉት እነዚህ ብቻ ናቸው እያለ ነው። ዋዮችን ፌል ያደረጉ ዋዮችን ቆጥሮ እነዚህ ናቸው። ይሄንኛው ደግሞ ፌል ያደረጉት እነዚህ ብቻ ናቸው እያለ ነው። አሁን ምን ይፈጠራል ማለት ነው? ዋይ ለምሳሌ አንዳንዴ ፓስ ያለውን ኤክስ ፌል ይችላል። ይሄ አሁን በእንትን ላሳያችሁ፣ ግልጽ ነው። let's say measurement device for roundness. There are a lot of technologies to measure roundness. You see, there are a lot of measurements for roundness. So, okay, single multi-channel meter conductor. Okay, I'll show that. Okay. Metro. Okay, these are like the prices for measurement. Okay, roundness. Rasu andu challenge no. Lemsale. When you go to under company student and the company كفتلين بله كذا ولا yeah, for example, these measures roundness. You see, this is also just measure roundness. So now the point is now you see this is the y, okay, y, and this is x, just like that, okay, x. So now you have like parts, part 1, part 2, part 3, and so forth like that. Part n, you see, part n, you have that, and you're gonna just measure it in x, and they're gonna give you measurement of x1, measurement of x2, and so forth like that, measurement of xn. When you just measure in y, it's gonna give you like y1, y2, and so forth like that. Okay, yn. You see, yn. So now, if I ask you, how do you determine the bias of this machine against this machine? How do you do that? How do you do that? How do you do that? Yes. Bias of okay. So how do you check like whether that's significant or not?
Do t-test, I think.
T, what kind of T? Paired or independent?
Paired.
Paired t-test. Yes, paired t-test. Paired t-test, because this measurement is paired with, you see, part 1, and part 1 is associated with this x1. Okay, just like that. They are paired. Those measurements are like paired. So we're gonna just apply paired t-test. Okay, paired. Okay, t-test. Test to determine bias. Okay, significance of the bias. Okay, bias, just like that, bias. So there are a lot of ways to calculate the bias. There are a lot of ways. One of the way is just put like this is y bar and this is x bar. Then you're gonna just subtract one another. Okay, y bar minus x bar. That's it. This is gives you the bias. Okay, the bias. But this bias might not be efficient. You got me? Efficient or effective. Can you tell me why? Efficient ላይሆን ይችላል ያ bias calculation ላይሆን ይችላል. Can you tell me why? ምን ነግረኝ የለም?
ማሽኑ የተሰራበት ስፔሲፊኬሽን የተለያየ ሊሆን ስለሚችል ነው።
Sumano technology different now. This technology is different from this technology. That's what you are looking here. The way is going to just organize the way it's like the reading, whatever, it's different. That's why we call it like X and Y.
Maybe the reliability of the machines.
What does this mean?
ማለት የማሽኑ ሪላያቢሊቲ አንዱ ሪፈረንስ የምናደርገው መሽን ምን ያክል ሪሌብል ነው የሚለውን ነገር አፌክት አያደርገውም።
We're not talking about that stuff. What we're talking is biasing estimate ለማድረግ ነው እኮ biasing estimate ለማድረግ y bar minus x bar inefficient ሊሆን ይችላል ያልኩት ነው። ግልጽ ነው ያልኩት። so ለምንድን ነው
የተለያየ linearity
the device stability is not checked, or if we are not sure with the device's stability, the measuring device stability.
No, አሁንም ስለ ስቴቢሊቲ ስለምናምን እያወራን አይደለም። ስለ ቁጥሩ ነው እያወራን ያለ ነው። ስለ ካልኩሌሽኑ ነው። ስለ ካልኩሌሽኑ ኦኬ ኢረር ኮንሲደር አላደረገም። አንድ እሺ ሌላ ኦኬ ቅድም እኮ ነግሬያችኋለሁ። አሁን ቤስት ሞዴል y equal to alpha plus x ከሆነ you see alpha plus x ከሆነ አቨሬጁን ውሰዱት እስቲ አሁን እዚህ ጋር alpha plus x ከሆነ የዚህ ሰም ውሰዱ የነዚህንም ሰም ውሰዱ just like that ማለት ነው። ይሄ ምን ይሆናል n times alpha plus the summation of x ይመጣል አይደል እንዴ? አይመጣም? ይሄንኛው summation of y ይሆናል። now divided by n, okay? When you put this one, what you get is this is y bar, y bar, and this is equals to this cancels out, and you get alpha plus this is x bar. You see x bar. When you just minus for this one, y bar minus x bar, and this is alpha, isn't it? So the bar is in order, but the model consider ያደረገው ግን ምንድነው ማለት ነው? model consider ያደረገው ምንድነው? y equal to alpha plus the most adequate model ግን ምንድነው ያልነው ቅድም? the most adequate model የሚሆነው the most adequate model y equal to alpha plus beta x ነው አይደል ነው? you see beta x ነው አይደል? so because we say this is the most reasonable one, so which alpha, let's say this is alpha naught and this is alpha 1, okay? Which alpha is best to estimate the bias? This is the best. That's the best. Okay, the best to estimate the bias. Estimate the bias. Okay? That's why reason we are normal. Just consider those two machines. So you have like this measurement and you have those measurements. Okay? Consider that. Now sort it. Let's say this is y1 star, y2 star, y3 star, and so forth like that. Y and star, okay? So but and x star 1, x star 2, sort ተደርጎና x star 2, x star 3, and so forth like that. Okay, x star, okay, and you see, just like that. So now we're gonna draw line here. We're gonna draw line. This is our spec. Just like that. This is upper specification limit, and this is lower specification limit. You see? You see? So these counters right here, እዚህ ጋር ያሉት ምን አድርገዋል ማለት ነው? ፓስ አድርገዋል አይደል? ለዚህም ፓስ አድርገዋል። ፓስ አድርገዋል። ፌል ያደረጉት እዚህ ጋር x fail in x, fail in x. These parts. These are fail in machine y and fail in machine y. Now, confusion matrix የሚባለው ምንድነው? These two numbers are not the same. These two numbers are not the same. They are not the same. Okay, these two numbers are not the same, and these two numbers are not the same too. Okay, just like that. Okay, actually are not the same, so may not be the same, may not be the same. Okay, so that is what confusion matrix means. Now we're gonna go and we're gonna try to do, you see this is machine y, okay, that way, and this is machine x. Okay, now our parameter is pass, fail. Okay, this one also in x we're gonna put like pass here and fail. You see? So just like that. So these counties minimal now y says those parts those parts pass, but x also says like this is pp. Okay, pp pass. Okay, this one says fail, but this one says pass. So this is failed, pass. Okay, this one says pass, but x says fail, just like that. And this says fail. Okay, so where is gauge agreement? Gauge agreement is this one plus this one, isn't it? That is gauge agreement. That is what gauge agreement is. But እዚህ ጋር ግን ምን እያደረጉ ነው ያሉት? ዲስአግሪ እያደረጉ ነው ያሉት አይደል?
Yes.
ያ ሶ አሁን ምንድነው እዚህ ጋር y ፌል ብሎታል፣ but x ግን ምን ብሎታል? ፓስ ብሎታል። ስለዚህ ይሄ ምንድነው የሚባለው? ፎልስ ፖዚቲቭ ይሄኛው ደግሞ x ፌል ብሎት y ግን ምን ብሎት ነበር? ፓስ ብሎት ነበር። ስለዚህ ይሄም ደግሞ ፎልስ negative. You see, just like that. Just like that. Okay, just like that. So from here we're going to define everything. Now sensitivity, CV, okay, sensitivity is equals to the sum pass, the number of pass divided by this row, the entire row, the number pass fail plus pass, okay, pass. That is sensitivity. And specificity is fail divided by fail pass plus fail, okay, fail. Okay, that is what specificity is. So this one is false negative rate and false positive rate, and this is false negative rate, just like that. So now there is another concept called ROC curve, or operating characteristics curve. So that is sensitivity. This is sensitivity. Sensitivity. Okay, versus 1 minus specificity. Specificity. So it's going to be a kind of curve. Okay, it's a kind of curve. Okay, right here, 1 minus specificity and sensitivity, just right, like that. So we have like 45-degree angle here, 45-degree angle here. So now you see the gauge is good. The gauge agreement is good if both sensitivity high, specificity high corner. A gauge agreement good norla. Good norla, yeah.
Yes. Yes.
Good no. On gauge agreement bad no. Way sensitivity the color, way the more specificity the color. One of that, that's bad. Okay, so sensitivity high shown, specificity high shown, 1 minus specificity low yonal, not low yonal, isn't it? When you consider this condition, when you consider that condition, if the specificity is high, so what is the maximum value of, let me say, 1 minus specificity? Maximum value is
0.
Maximum value ma 1. Minimum no 0. Minimum 0.
Yeah.
So let's see. What is our expectation if the gauge agreement is good? If the gauge agreement is good, you see, our expectation is going to be, you see, sensitivity, yeah, sensitivity, and 1 minus specificity. So at lower end of 1 minus specificity, we're going to expect high sensitivity, okay, high sensitivity. So if operating characteristics curve እንደዚህ ያለ የሚመጣ ከሆነ እንደዚህ አይነት ከእንትኑ ከ45 ዲግሪ በላይ ከሆነ በዚህ ጊዜ ጌጅ አግሪመንት is good. Good gauge agreement. Good gauge agreement. You see? Gauge agreement. Otherwise, if it's gonna just go to, you know, like just like that, በዚህ በሚመጣ ከሆነ ግን bad gauge agreement ነው. Bad gauge agreement. You see? Agreement. ግልጽ ነው አይደል?
ግልጽ ነው.
Good. So let me see if I have data on that. Let me. Okay. Pass, fail, or whatever. Gauge agreement, just like that. I have that. Okay. So let me take this data. Okay, pass, or whatever. Oh, okay. You know, there are outcome. I don't know. Okay, let me. I'm okay with this. So, okay. Okay. So let me do some. Okay. Okay. Let's make it like this. Fail pass. Okay. Hey, example, no, she. Okay, so now just example. So just to show you operating characteristics curve. Soon we change the type now. What is operating characteristics curve? We don't. lemon mark. Okay, so just like that. So now let's go to start and predictive analysis and this classification. And then let me put okay, now here responses agreements, okay, gauge agreement and continuous variable, okay, against calibrated gauge, okay, we're testing these things against calibrated gauge. Then I'm going to say okay. So when I say okay, this is what I get. Okay, this is what I get. Pass event, just like that. Variable, just target event. Okay, this is classification matrix. That's not real. Okay. So you see, ROC curve, area under ROC curve. That is from this to this. Okay, like your tests are already given, just like that. So now, pass, fail, fail, fail. Okay, so you see, true positive rate or sensitivity, that is 76%. This was expectation. This was expectation, but the real value is 71%. False positive rate, 36%. False negative rate, 28%. And specificity, 64%. So now this is the ROC curve, okay? This is the ROC curve in this test, the ROC curve. You see? Let me take this copy graph. Let me put this information just here. I'm going to put that. You see? Now, what did I say is that this is 1 minus false positive rate, or 1 minus specificity is given here. And this is true positive rate, or we call like sensitivity. So what we say, this is the reference line, okay? This is reference line. Reference, okay, line for the gauge agreement. So if the reference line just like that, and you see at low, when this one is low, okay, low, as you see here, you see low values of right there, all the curve, okay, or the curve. Test is the one that we are going to be looking, okay. Test is this, test is the curve. That's what we're going to do. So sensitivity values are above what? Above like this line whenever this is given. So in this scenario, the gauge agreement is good. Okay, good. So that is what's going to be our conclusion with respect of like studying those things. And now, this is very important topic. I think you need to learn more on this topic, how to do binomial test, how to do like a ROC curve or whatever. So like gauge concordance, how to do like gauge concordance or study between two different gauges. So tomorrow you might just develop, like as an engineer, you need just to develop a gauge. So when you develop a gauge, how you are going to make it like validated. So there are gauges that are already in the market. So can we replace those? Then we do all this analysis to verify that gauging system is okay. Okay. So I might just ask you just to develop a gauge, pressure gauging car. I might just ask you sensor gauge in a car, temperature sensor. Or I might just ask you just to do ampere or voltmeters for a house. So these are all like gauges, okay? So you need to do all this calculation to reach out your final goal line. So this is about like gauge concordance. So do you have like any question here? any question?
Yes, Professor.
Okay. Go ahead.
ማትሪክስ ላይ ፎልስ ኔጌቲቭ እና ፖዚቲቭ ኔጌቲቭ የምንለይበትን እንትን አልገባኝም። ሁለቱም ላይ ማትሪክስ ላይ
እንዴት ነው የማይገባ? ይሄማ ምንም ፎርዋርድ ነገር እኮ ነው። አንደኛው ጌጅ አንደኛው okay. We already just did these things. I don't know. It's like ፎከሳችሁ የት እንደሆነ አይታወቅም እንጂ ይሄ በደንብ ኤግዛምፕል ሰርተናል እና it's like let me go ይሄማ ቀላል ነገር ነው እንደውም ሌላ ስንትና ስንት የሚከብድ ይሄንን ካልተረዳው እንዴት ነው ነገር ይሄ let's say አሁን assume Excel ደግሞ ቢላል አይደል አንድ okay so now okay ይሄንን እንውሰደው እስቲ ለምሳሌ እና ሁለት ጌጆች ናቸው ብለን እናስብ oh my god okay there are you got like two gauges now ይሄንን የመጀመሪያው ላይ instead of like this is like gauge why level አንተ ደስ እንዲለው ይል እሺ እየሰማኸኝ ነው አይደል okay ገብሬ okay so now you see ይሄ y ይሄ x አሁን ስፔሲፊኬሽን አለን ብለን እናስብ ሜጀር እየተደረገ ያለው 80 ነው. This is your lower specification limit and upper specification limit. ይሄ ደግሞ 110 ነው ልበል 110 okay 110 just like that okay so now ምንድነው እናደርገው ይሄንን ፊልተር እናደርግና ፊልተር እናደርግና ከዛ በኋላ ከ80 እና ከ110 በላይ አሁን እዚህ ጋር y ነው ፓስ ያደረጉትን ዋዮች ነው ካልኩሌት ታደርግ ይሄንን ለማድረግ ምንድነው ታደርገው ከ80 እና 110 ነው ስለዚህ ኤ ፌል አድርጓል ማለት ነው አይደል ፌል አድርጓል አይደል ለካርሎ እንደ 110 እነዚህ በሙሉ ፌል አድርጓል ማለት ነው ኦኬ ዋይ ፌል አድርጓል እያለ ነው እነዚህ ፌል አድርጓል እያለ ኢኳል ሰር አሁን ይሄ ምን ይሆናል ማለት ነው ፓስ ብቻ ይሆናል ማለት ለዋይ ነው እንግዲህ ለዋይ እነዚህ በሙሉ ፓስ ያደርጉ ናቸው ማለት ነው ኦኬ so similarly we're going to take all of the data okay then similarly I'm going to say okay then okay x pass then I'm going to come here this is failed okay this is pass እስከ 110 ድረስ ነው ያለው ይሄ ፌልድ ናቸው እንደዚህ በሙሉ ኤክሶች አይደል just like that like this okay then I'm going to say okay so ይሄ ምን ሆኗል ማለት ነው x እዚህ ጋር ምን አድርጓል ፓስ አድርጓል ማለት አይደል just like this x እንደዚህ ሆኗል ማለት okay then I'm gonna put all of this then እዚህ ጋር ይሄን ሶርት ማድረግ ይችላል I don't think so filter አላረገው መሆን አይችልም already filter ስለሆነ so ምንድነው ማረጋው okay anyway ሊያጽፈኝ ነው ማለት ነው ግን እንደሱ ሳይሆን ሌላ sheet ላይ ልሰደው ማለት so I'm going to put it right here so እዚህ ጋር ፊልተር አደርገዋለሁ ፊልተር አደርገውና ከዛ አሁን ምንድነው ማረጋው ፓስ ነው ያለው okay select all just like that okay pass channel okay እዚህ ጋር pass okay ምንድነው ዋካሽ ሊያጽፈኝ ነው ማለት ነው ሙሉ ለሙሉ anyways I don't know what I'm going to do ይሄንኛው ፌል ነው ማለት ነው አይደል ፌል ነው fail just like that this is just fail this is also fail okay ሁሉንም ሊያጽፈኝ ነው መሰለኝ fail just like that so these are fail okay this is fail ለዋይ ነው እንግዲህ ያየውን ያለውት ዋይ ነው okay ለዋይ ነው fail so this is fail or do not pass the test fail this is fail then okay this is also fail okay and this is fail and this is fail this is fail you see just like that so now we're going to come to for x okay for x okay pass actually እንዴት ነው አንድ አይነት ቁጥሮች ናቸው የተወሰዱት ስለዚህ አሁን እዚህ ጋር ምንድነው የምናደርገው ማለት ነው ይሄ ምን ሆኗል ማለት ነው ፓስ አይደል pass pp ይሆናል ማለት okay let's say እንቺ 108 ነች ልበላትና 108 x ፓስ አድርጋ ነበር እዚህ ጋር ደግሞ ምን ትሆናለች ማለት ነው fail pass ትሆናለች ማለት ነው fail pass okay አሁን x እዚህ ጋር fail ብሏታል y ምን ሆነ ነበር it's like ይሄ አግሪመንቱ ነው ማለት ነው agreement ስለዚህ እንዴት አድርገን ነው የምንቆጥረው ማለት ነው ይሄ pass ይሄ fail ይሄ pass fail pass ይሄ fail እዚህ ጋርም ለምሳሌ 104 ልበለውና ቁጥሩ ጥሩ ኤግዛምፕል ሰላደረ ነው let's say ይሄ pass ቢሆን just like that ይሄም fail pass ሆናል fail pass እንደዚህ ያረክት ቆጥራቸዋለህ this is how you're going to just do እንዴት አድርገን እንደምንቆጥራቸው ይሄ ነው ሜቶዱ ማለት ከዛ በኋላ y አጠቃላይ ስትመጣ y በዚህ በኩል ታረጋለ x በዚህ በኩል ታረጋለ then this is fail okay x is going to be here then ziga pass then fail so ziga pass this one is fail pass this one is pass fail and this is fail just like that this is how you fit your confusion matrix so it's going to be just like that ስለዚህ እዚህ ጋር ያሉት ቁጥሮች ናቸው አይደል ያንተ ኮንፊውዥን ማትሪክስ ዲተርሚን የሚያደርጉት እንደዛ አድርገን ነው የምትቆጥራቸው ማለት ደፈተይ አቤት ሄሎ ነው
ፕሮፌሰር አይግልጽ
ኦኬ then ቅድም ያልነው ይሄንን እንዳለ ተወስዱታላችሁ bias አለ የለም የሚለውን ጀነራሊ ለማወቅ እዚህ just like that. So on እዚህ ጋር ትመጣና start t-test pair t-test like pair t-test. So you're gonna put sample 1 y, sample 2 x, then you're gonna just do options 95%, graph, box plot of difference, individual plot, and you're gonna do like this. Then it's gonna give you, you know, the mean of y is this, the mean of x just like that. So the estimator of the difference is 0.98, and the confidence interval just like that. So the confidence interval contains 0. That means the bias is insignificant. The bias is insignificant. Then you're gonna go to regression test, fit linear regression. So you're gonna put like response is y, and here is just x. You're gonna put x just like that. Then okay, this equation y equal to 1.13. So you see, previously, right here, bias ስንት ነው ብሎ ነበረ? 0.98 ብሎ ነበረ። Regression test again, bias ስንት ነው እያለን ያለው? 1.13 እያለን ያለው. So which one is the best here? ይሄ ነው best estimator ወይስ ይሄ ነው best estimator? የትኛው?
Regression.
The second one.
Yeah, regression. The 1.13 is the best, because there is no 0.99, you know, 86x. Okay, 86x. This is the portion of x that matches with y. The rest is just every regression fit, whatever. That's thing is good. So now we do, okay, just like that, just like this. Then we're gonna do test. Okay, so we have the measurements just like that. So here we're gonna put regression line. Okay, so this is the line. So as you see here, everything is okay, except, you know, these values are outliers. These values might be just outlier. So the test here is gonna give you those observations. Okay, observation 2, observations 3, 5, and 15. They are outliers. Okay, they are outliers. So you can avoid them in doing your calculation. You got me? In doing your calculation. ምንድነው እዚህ ጋር recommend እያደረገ ያለው? Observation 2, 3 ምናምን እነዚህን አጥፋቸው ነው። ስለዚህ እዚህ ጋር መተን እነዚህን ኦብዘርቬሽኖች አጥፍተን የተሻለ ኤስቲሜተር መስጠት እንችላለን ደግሞ ማለት ነው። Observation 2, this one is observation 2 ማለት no, this is 1. Observation 2 ይሄ ነው። this one ይሄንን አጥፋው። ከዛ በኋላ observation 5, is that observation 5? 5, yeah. 1, 2, 3, no. 1, 2, 3. Y is 1, 2, 3. Y is 1, 2, 3. Yeah, I think this one is 1, 2, 3 or whatever. So anyways, ምን ማድረግ ትችላለህ ማለት ነው እነዚህ okay, because your residual diagnostics is going to just tell you they are not good number, then you're going to determine whether those things are okay or not. Okay, I mean, needs to be just included in the study. Okay, so this is all about like gauge concordance. So there will be assignment for you you're gonna just do an exercise. Okay, exercise. ጥያቄ አላችሁ እዚህ ላይ? Any question? Any question? ጥያቄ አላችሁ ወይስ የላችሁም? የላችሁም?
ፕሮፍ አንድ ጥያቄ ልጠይቅ።
እሺ ጠይቀኝ።
measurement አሁን ለምሳሌ ኤክስ እና ዋይ ሲንግል measurement ነው ያለው እና replication ቢኖረው እና በተለያየ ፓርት ሳምፕሊንግ ስኬል ወስደን measure የምናደርገው ከሆነ ለምሳሌ ኤክስ ለኤክስ ለmeasurement 1 ዲቫይስ ከy1 እስከ y10 አካባቢ ለኤክስም እንደዛ ብናረግ ኮንቪዥን ማትሪክሱ በምን መልኩ ነው ማኔጅ ማድረግ ይቻላል? እንደዚህ
ምን ማለት ነው? እኔ ጥያቄ አልገባኝም።
የሁለት አሁን ለምሳሌ ለመልቲ ሲሆን ማለት ነው በሌላ አገላለጽ መልቲ ሜዠርመንት ሲሆን የዲቫይሶቹ with multi times በዱፕሊኬሽን ሊሆን ይችላል ሪፕሊኬሽን I don't know
ያ
እንዴት ነው የምናደርገው?
እዛ ፋክተር ታስቀምጣለህ። አክቹአሊ እዚህ አንዳንድ ነው ዩዥዋሊ እንደዚህ አይነት ጊዜ የምታደርገው ማለት ነው። ኦኬ ሲንግል ፔር ነው የምታደርገው። ግን አሁን የምትለው አንተ ምንድነው? ለምሳሌ ፓርት 1 ኦኬ ፓርት 1 just like that part 1 አሁን yes part 1 ስንት የተለካ አንድ የተለካ አይደለ? Okay, insert z. Let y and right here. Okay, x. The same thing. So right here, 88 here, 87 here, 86. Limit extra. So this is like ziga demo 89, 88, 90. Just like that. This is for x. So it doesn't matter. It doesn't matter. But you already just add here one factor, right? You already just added like one factor. Y equal to okay replication alpha plus the effect of replication, that is beta plus gamma times x on alpha. Right? This is the effect of replication. Or repeatability. Okay, repeatability. Whether the gauging system whether they are repeatable ናቸው which ደግሞ አይደሉም የሚለውን justify ለማድረግ ነው ማለት ግልጽ ነው። ልክ እንደዛ ግን እንደዚህ አይነት ሞዴል ብዙ ጊዜ የለም አንጠቀምም። like ብዙ እንደዚህ አይነት ነገሮች እንትን ብላ ጌጅ ሬዳር ላይ ነው እነሱ መስራቸው። ግልጽ ነው።
Okay, cool.
Okay.
Thank you.
Okay, great. Gauge radar, linearity. No linearity. Let me search. Okay, let me do my search. Okay. So now አሁን gauge linearity ላሳያችኋለሁ። Okay, gauge linearity. Let's learn something about like gauge linearity. On gauge linearity, you have okay here insert okay something table. I don't know. Okay. Okay. Home. Okay. So now let's assume like we have like a gauge x and suppose these measurements, okay, or gauge linearity ምንድነው? ባለ አራት specification ይኖር okay So at 4, let's say at 4, you got like 3.8, 3.5, 4.2, 4.22, 4.3, and so forth like that. You see, this is for measurement, and now you see this is just for bounded by like diameter of like 4, okay, and you have like, let's also, you have bounded by 5 or like 6 diameter የሆነ እንደማለት ነው። 4 ማለት let's say 4 diameter of just 4 ይቺን በላት, okay, then 6, let's say 6.22, 6.5, 6.8, 6.84, 7, 6.88, just like that. So አሁን ይሄ ደግሞ ምንድነው ለትልቁ ሲለካ ነው እንደዚህ ይሄንን ቫሪያንስ የሚያሳዩ ተለቅ ላለው ሲለካ ነው። አሁን ሁለቱ ሰርክሎች የሁለተኛው ትበልጣለች። let's say you got also like 10 እና 10 አካባቢ ያሉትን ሜዥር ለማድረግ የሚጠቀምበት, let's say is going to just measure this one 9.9, 10, 10.2, 10.2, 10.3, 10.44, 10.5, okay, just like that. So this is associated with, you know, like this big circle. So now when it measures like those, it has like its own like bias, okay, its own bias, you see right here, okay, it has its own bias, and when it measures this one, it's also its own bias, and when measure, you know, big just like that, its own bias. So this is let's say bias 1, bias 2, and bias 3, okay. So now if bias 1 equal to bias 2 equal to bias 3, then the gauge has no linearity problem. Then the gauge, okay, the gauge has no linearity problem. Else there is a linearity problem. There is a linearity problem. Okay, you're gonna think of that way. So now let me put this just like that. Let me put circle, okay, just like that. So this is 4, okay, this is 6, okay, ቁጥራቸው እኩል መሆናቸውን ግን አረጋግጡ, okay. So how many 4 are here? 5. 1, 2, 3, 4, 5. 1, 2, 5, 6. Okay, let me insert
16.
Okay, 4. Let me put this one's 4, 3, 3, just like that. Now 5, 6. So they are good now. So insert, so scale and measurement, just like that, okay. So we're gonna copy this and put in Minitab. Let me add that. Just put it like this. So start. Where's gauge study, quality tools, gauge study, then linearity and bias study right here. So part numbers, you see scale, okay? Measurement, okay, reference values. Okay, reference values. Let me do that. Okay. So let me arrange it in this way. Part number, let me add that here. Where is it? Let me add this one, part number, PN. So this is 1. Yeah, 1, 2, 3, 4, 5, or whatever. It doesn't matter. Just like that. No, 1, 2, 1, 2, 3, 4, 5, 10. So I think this is good now. Okay, so let me put that. I'm gonna put here. So now, okay, this is quality tools, gauge study, linearity. Okay, so part number, let's say PN, and the scale is a reference value. And measurement data, then we're going to put that one. Process variation, I don't put that stuff. Okay, gauge information or whatever you're gonna put here. Gauge name, gauge X, you know, some stuff. Date of the study, let's say March 18, okay, 2023, okay, reported by, say, YYT. You're gonna put whatever, 0.9 or miscellaneous, whatever, but just needed because this is a report, needed, important report. And options, sample range, you don't need. Then you're gonna say okay. So now you see, this is the gauge linearity report. And linearity objective movement. You see, linearity objective, okay. የጌጂንግ ሲስተሙ ሳይዞቹ በጨመሩ ቁጥር ባያዙ እኩል ነው አይደለም ገብቷችኋል ላይክ ዌይት ስኬሎች ለምሳሌ አሉ ዌይት ስኬሎች አሉ እነዚህ ዌይት ስኬሎች በማይክሮግራም የሚመዝኑ አሉ አይደል በግራም የሚመዝኑ አሉ በኪሎግራም የሚመዝኑ አሉ በቶን የሚመዝኑ አሉ ሁሉም ምን አይደሉም እነዚህ እንትኖች ጌጆች ማለት ነው ሁሉም ጌጆች ምን አይደሉም it's like እነዚህ ትንንሾቹን ዲቴክት የማድረግ አቅሙና like ሜዠርመንቱ ደግሞ እየጨመረ ሲመጣ ሜዠርመንቱ ዲቴክት የማድረግ አቅሙ እየተለያየ ነው የሚመጣው እሺ okay. That is what gauge linearity means. Linearity. As you see here, so the average is this value, the average bias is this value. So whenever it measures 4, it might just have a bias of 0.0005. Okay. 6, 0.7, all Samsung. And 10, 0.2222. So in this scenario, as you see the p-value here, they are all insignificant. So in this gauging system, no bias in this scenario. No bias. If there is a bias, then this slope, you see here, it is insignificant. The slope is insignificant. That shows no bias in the system. No gauge bias in the system. So right here, whenever it's gonna just measure for 4, you're gonna put that right there. So this is the average for the bias. Whenever it's gonna just measure 6, it's gonna just put like that. And whenever it's gonna just no 8 here, actually, it should be 8, just to get it like equal interval of like, you know, what measurement, whatever. Then whenever it's gonna just measure like 10, here is the average of the bias. This is the overall bias. That is the overall bias. So in this gauging system, in this example, okay, in this example, no bias problem. Okay, linearity is not a problem. Linearity is not a problem. A problem. Okay, as you see, those numbers are really very close. So if they are like different, or if this one is significant, and it's going to just show you whether linearity issue exists or not. So more examples generate ማድረግ ጥሩ ነው። እነዚህ ለምሳሌ when you develop like electron microscope, በኳንተም ስኬል ያሉ measurement ዲቫይሶች ላይ ሲወሰድ እነሱ ያላቸው የባያዝ መጠንና በትልልቅ ስኬል የሚለኩ ማሽኖች የነሱ የባያዝ መጠን ይለያያል። Okay, that's what we're gonna just call like gauge linearity. That is what gauge linearity means. So do you have like any question here? Let me know. Any question? Any question? ገብቷችኋል ማለት ነው። ጠጥታችሁታል ማለት ነው ነው ወይስ እንዴት ነው ነገር? አነግሩኝም እንዴ?
ሄሎ ፕሮፌሰር።
አቤት አቤት።
የአሁኑ ላይ ቢያዛችን ተመሳሳይ ነው እያለን ነው አይደል?
ያ አሁን ምንድን ማለት መሰለህ? ለምሳሌ ወርቅ የምትለካባት ሚዛን አለች አይደል?
ያ
ስኳር ደግሞ የምትለካባት ሚዛን አለች አይደል?
ያ
አሁን ለምሳሌ ወርቅ የምትለካባት ሚዛን ግራሞችን ትለያለች።
አዎ ዲቴክት ታደርጋለች።
ግራሞችን ማለት ነው።
ያ
አሁን ስኳር የምትለካባትም ደግሞ ግራሞችን ልታረግ ትችላለች። ኪሎችንም ታረጋለች። ኪሎችን አሁን ወርቅ የምትለካበት ቦታ ላይ ኪሎ ግራሞች ወስደህ ሜዥር ብታረግ ማለት ነው ያ ምን ሊያደርገው ይችላል? ይችላል እዛ ላይ የሆነ ባያዝ ሊፈጥር ይችላል። ገብቷል? ወደ ላይ ሲሄድ ማለት ነው። ስለዚህ ይሄም ስኳርም ስትለካበት በረው ወደ ታች ተወስደው አቅም ላይ ኖረው ይችላል። ስለዚህ አሁን ይሄ ጌጅ አዲኩዌት የሚሆነው ለምሳሌ ወርቅ የሚለካው ጌጅ አዲኩዌት የሚሆነው ከ1 ኪሎ ግራም በታች ሊሆን ይችላል። እሺ or ከ500 ግራም በታች or whatever ከዛ በታች አዲኩዌት። ከዛ በላይ ግን የሆነ ባያዝ ሊያመጣ ይችላል። ግልጽ ነው? ከዛ በላይ እየወጣ ሲመጣ የሆነ ባያዝ ሊያመጣ ይችላል። ልክ እንደዛ ሁላ አሁን ኤሌክትሮን ማይክሮስኮፕ አለ። እንደገና ደግሞ ማይክሮስኮፕ አለ። ኦኬ ማይክሮስኮፕ አሁን ማይክሮስኮፕ ለምሳሌ የባክቴሪያ ዲያሜትር ወይ ደግሞ ቁመት ምናምን ይናገራል አይደል? አሁን እሱን ኤሌክትሮን ይበት ብትለው ኤሌክትሮን የማየት አቅሙ ምንድነው ነው? ግልጽ ነው? የለው እዛ ጋር አሁን በኤሌክትሮን ደረጃ ተመሂድና ተመልከት ብትለው የማየት አቅሙ። ስለዚህ ያንኛውን ጥሩ የሚሆነው ምንድነው? ባክቴሪያ አሜባ ምናምን ለሚሆኑት ማይክሮስኮፕ is good ለነሱ ማለት። ከነዛ በላይ አምጥተህ እያደገ ለምሳሌ ትልቅ ሳንቲም የሚያክል የሆነ ሜዠርመንት ብታመጣ እሱ ጋር ዲቴክት የማድረግ አቅሙ ማግኒፊኬሽኑ ሌላ ነገር እያደረገ ነው የሚነገባ። ሶ ያንን ባውንድ የማድረግ ጉዳይ ነው። አሁን ምንድነው አሁን በእናንተ ኤግዛምፕል ጌጅ ሊኒያሪቲ ኦኬ ይሄ ነገር ያስቸግረኝ ኤኒዌይ we'll see that one. By example አሳያችኋለሁ maybe another time you know what ግን እንትኑ ሳይዙ እየጨመረ ሲመጣ ጌጁ ዲቴክት የማድረግ አቅሙ ምን ያህል ነው የሚያሳየው ባያዝ ምን ያህል ነው አሁን ሆሪዞንታል ላይን ከሆነ ኖ ባያዝ ማለት but either increase የሚያደርግ ከሆነ ከሳይዝ ጋር or decrease የሚያደርግ ከሆነ ከሳይዝ ጋር then there will be bias ማለት okay just like that.
Thank you.
Okay so MSA2 is this is all about gauge precision okay precision yeah so precision when we talk about gauge precision there are two concepts important concepts one is repeatability the other is reproducibility just like that okay reproducibility so this is the variation of the gauge okay when we say gauge repeatability this is the consistency of the gauge okay that's what means and gauge reproducibility is the consistency of operators who use the gauging system just like that okay that is what we're gonna just consider or we're gonna deal all about okay so most industrial problems are solved using this knowledge okay or MSA2 is all about gauge R and R studies okay gauge R and R studies so we're going to look at each what does it mean okay what does it mean okay so now we're going to consider okay what gauge R and R means okay gauge R and R okay R so to determine what it means suppose you have like measurement okay y is your measured value and this is decomposed into the mean or this is the target of the specification this is the target of the specification target of the specification plus okay alpha I is a part-to-part variation this is part-to-part variation part variation okay variation plus the skill sets of the operator that is beta j okay operator variation operator 2 operator variation okay variation plus random error ijk here yijk so this is the design of experiment specification for gauge study okay for gauge study DOE specification spec okay design of experiment specification so what we want is if our gauging system is okay Now, if operator to operator, if they are okay, you see, if the gauging system is okay, then like if assume like all the operators, their knowledge and their skill is perfect on doing like the gauge. In that scenario, this term is gonna vanish, isn't it? Vanish. Okay. Again, this term, part-to-part variation, that's gonna be just if the part-to-part variation in production, that's perfectly good, then this term is vanished. Okay. What's left is y. Okay, y equal to simply the target plus your I, J, K. This is what's left. So this is what we want, okay? This is what we want. ይህንን ነው እኮ እኛ የምንፈልገው አይደል? እኛ የምንፈልገው ዋይ ታርጌቱን ሜዥር እንዲያደርግ ነው በቃ። ይሄ ታርጌቱን ሜዥር እንዲያደርግ። So the point is, this is not happen. This is not happen. This is not happen. Okay, this is not happen because of a lot of things. Why it not happen? Why it not happen? Because now part-to-part variation, part variation. Okay, variation. Okay, where the part-to-part variation is come from? Okay, let me go and show you. Part variation. Okay, that is the variation in the gauging system. I mean, in the production, in production. Okay, let me do. I mean, let me show you what it means. So I'm going to show you. I don't have any. Okay, so why the part-to-part variation come is this is because of process variation. Process variation. Okay, suppose you want to produce some cans. Okay, suppose you want to produce some cans. Now these cans, okay, this one. Okay, you produce this can. Okay, you want to replicate it in the same process. You got also this. Okay, you're gonna try to replicate it again. You produce that, and just like that, you know, just like that. Okay, just like this. Okay, so now you are interested in doing like the height. This might be a little bit shorter. This might be a little bit bigger. This one is a little bit shorter. This one might be just like that. So what you expect is that some height, okay, this height, you want to hit that height. This height is your target, okay? Target. But when you produce them, this is gonna just show you just like that. That is because of what? Process variation. One aspect is that. Therefore, why we expect is gonna be decomposed into mean, but because of like process, it has like beta J, no alpha I. Some effects at least. Okay, some effects. So this is plus alpha I. You see, that is what process variation means. Similarly, when we come to in production, operator to operator variation. Operator to variation. So this means Okay, you have one operator here, very skilled, very professional. This is a young engineer, and this one is very not curious. Okay, so they measure the same part. Okay, they measure the same part. Okay, I gave them just to measure this. Okay, to measure this, and okay. Okay, how's that so? How's that happen? Okay, game back. Yeah, okay. This is what I want. I gave them the same part to measure. Okay, I gave them the same part to measure. So now, this one might just measure it like the parties, you know, just like that. So this operator might over measured it over from the spec. And this one is measured exactly, this one measures, you know, under, just like that, under. Okay. So it's not the part actually just showing the variation. It is showing these people's variation. Okay. These people's variation. These people has not the same kind of like skill to these people. Okay. These people, communication between that, those. I mean, the skill sets of, you know, these people, just like that. So if we use micrometer, so, you know, when you just measure it, you're gonna target here, like on micrometer ስትጠቀም እንዴት ነው? አሁን ቺኛዋን ነው አይደል የምታዞራት? ቺን ስታዞራት እቺ ወደዚህና ወደዚህ ትመጣለች። ስለዚህ አንዳንደኛው በደንብ አድርጎ ያዟዙረዋል፣ አንዳንደኛው ግን ስሙዝሊ ለቀቅ ያደርገዋል። ኦኬ this is their measurement style. So መደረግ ያለበት ምንድነው? like that. Okay, you don't need just to push it. You don't need to make it like more harder on this micrometer. So in this scenario is going to create some kind of like bias because of like the operator. So because of that, what will happen is our gauge equation, you see our gauge equation becomes y equal to the target, that's what we want to measure, plus alpha I, which is part-to-part variation, plus beta j, the operator skill sets difference, plus error I j k. Okay, so here repeatability means we already said, okay, repeatability is the consistency of the machine, consistency of the machine or the gauging system. Then reproducibility is operator skill sets. Okay, whether the reproducibility means like operator is going to just reproduce the same measurement. Okay, replicate the same measurement, but you know, just like that. That is reproducibility. This is the measure of standardization. Standard work procedure plus train the operator about how to measure. Okay, how to measure. You're gonna just train the operator how to measure. So now in MSA2, so total gauge variation, gauge R and R variation is the sum of the variation of repeatability or repeatability rep plus reproducibility. Reproducibility. This is total gauge R and R. So now the scale is if total gauge R and R, if it is less than 10%, okay, less than 10%, this is acceptable gauging system. Accepted. If total gauge R and R in between, okay, in between like 10 to I think 30%, this is accepted but needs improvement, okay? Okay, but needs improvement. Improvement. G R and R is greater than 30%, not accepted. Not accepted. Accepted. That's what it is. Okay, not accepted. So now we are going to see how to do gauge R and R. Okay, how to do gauge R and R. Okay, gauge represent. Okay. Let me see if I have sheet one. Share. I think I have, yeah, gauge R and R. Okay, so here, you know, feature is outside diameter, part is given right here, part number, and the gauge is, this is a gauge, okay? This is a gauge, millimeter, strap, micro. And who's gonna be do, this is gauge lab person, it's conducted in 2015. Okay, gauge tolerance is this value. Gauge tolerance is, this is equal to upper specification limit minus lower specification, okay? Gauge tolerance means. That is what gauge tolerance means, okay? So now, there are 3 engineers or operator. One is David, Eric, and Frank, okay? So these are like the parts, okay? These are like the parts. How many parts does they measure? 10 parts, 10 parts. How many times each part measure? 3 times, 3 times. So I'm part of 2 ለምንድን ነው 3 ጊዜ measure ማድረግ የተፈለገው? Any person who's gonna just, why do we measure the part, measure 3 times?
Consistency of the machine.
To check the repeatability.
Repeatability. This is the measure of repeatability, okay? Repeatability this one. And part of 10 የተደረጉት part to part variation ለማወቅ ነው። Why 3 operator? Whether, you know, these operator are okay in using the gauge or not, okay? So I will show you how to do this. Then here, let me take that, okay? Let me copy this. I'm gonna go file, new, okay, new, okay. So here, I'm gonna do like this. Insert. Okay, so How many parts measure here? 10. What is this? Let me delete that. Okay. Just like that. These are parts, isn't it? Parts. And this is what trial. Trial 1, trial 2, trial 3. So what I'm going to do is this one, I'm going to copy it 3 times. 1, then 2, 3 times. And this is the first measurement. This is the second measurement. Cut it, paste it. This is cut it and paste it like that. Okay? Like that. We're okay now. Now this is the measurement. Measurement. Okay. Parts, measurement, just like that. So part, what I'm gonna do is I'll show you. This is one I just finished, but who is the operator for that one? Who is the operator? It is David. Okay, David is. So okay. This measurement is done by what? Who done this measurement? Insert operator. Okay. Operator. Who is the operator? David is. So drag it down, just like that. So I just finished for 1%. Okay, for 1%. So the second measurement, I have all these parts. Okay, or I can do it here. Okay, to not mix it, I'm gonna do it here. So the second measurement, this is the second measurement. Okay, then actually, okay, I'm gonna do like this, like that. Then this is just put here, paste. No, not like this. I'm gonna revert it, transpose. So then cut, okay, this one, cut. Put it here. Okay, then put it here, cut, like that. So who did this measurement? Okay, is that Eric?
Yeah.
Eric Saska. Eric Saska was by my friend. Okay. So, okay, this is Eric. Okay. So Eric, just like that. Okay. So parts, the same part, you see? The same parts. So I'm gonna put it here, just like this. Then this one, cut, cut. Then where I'm gonna put it here, I'm gonna put it here. The second one is done now. Okay. The third one, okay. Third one is, I don't know Frank. I know only Eric here. Maybe David Space. I know them. Okay. Okay. David Space. So here, I'm going to transpose, do like this, cut like that. Here, we're going to do here, just like this. Okay. So parts, just like this. Okay, who is that person? Frank. Frank. I don't know. Frank or France? Frank C. Okay, Frank C. You see, just like this. So I'm going to drag it down like that. Okay. Then I'm going to take this all Okay, do like that. Okay, now good. So I'm gonna take these all information as it is and copy, then put in new worksheet, and I'm gonna put right here. Like that. So go to Stat. You're gonna go to Stat. You're gonna do quality tools, gauge study, and crossed. Okay, this is crossed study, not nested. Nested. I'll show you the difference between crossed and nested. Then this is crossed, gauge or render study crossed. So here, part number, then parts. Operator, okay, operator. Measurement, okay. ANOVA, every information. Gauge information. Gauge name. What is the name of the gauge? This is the name of the gauge. Okay, Maher or whatever. Millimars, snap, micrometer. So I'm gonna put that. Okay, study date, what we're doing today, okay? March 13, 2023, no, March 18, 2023. Reported by, okay, Yohannse. Just like that. Gauge tolerance is this information. This is. Okay. But I'm tightening what it's going to give you, okay? Tighten, you see? Tighten. Then we're going to put that information where, okay? Then storage or whatever, then I'll show you. Then we're going to go. So now, before I can do this, okay, I can study a lot of things. Go to Stat, ANOVA, one way, response is your measurement, and factor is operator, okay? Do operator as a factor. Then graph here, box plot, okay? Box plot. Then you're gonna look at, this result is gonna tell you, you see, there are like 3 operators. They're gonna measure, and the p-value is right here. That's insignificant. So all the operators are okay. This is what's showed for. But David showed little bit variation. Eric is less, more precise, Eric, followed by Frank. Okay, just like that. But the mean, as you see, they're already right there. But like the most important thing is to see this value, But that is, the p-value is greater than 0.05. In that scenario, we're going to say, okay, those people have like consistent knowledge, experience, skill set, in doing like the measurement. Again, I will do the same thing. Instead of operator, I'm going to put like the part. Okay, I'm going to put the part, the same, everything the same. So here, you see, part-to-part variation is significant. That means when we just produce those parts, 1 to 10, then we see that one part is different from the other. As you see right here, we want those parts to be aligned, somewhere else, aligned. But part, for example, 1 is very bad part. Okay, very bad part. That means like, this is telling you, okay, as like, let's say, I'm gonna also just perform, okay, comparison. Feature. I'm gonna put that, and I'm gonna say okay. So this is all like the comparison. one part to the other. They're trying to be like just measure, but like as you see, part to part variation is significant. Okay, significant. So part one measured from here to here to here, the box, the variation. So that means there is error associated with the gauging system, repeatability. Part two, you know, is going to just measure like that. See, all the measurement as you see here, you see ምን ምን ነበረበት? ለምሳሌ ጌጁ እንትን ቢሆን ኖሮ አሪፍ ጌጅ ቢሆን ኖሮ ምን ይሆን ነበር? ጌጁ ምንም ቫሪዬሽን ባይኖረው ምን ይሆን ነበር? ይሄ ቦክስ ፖይንት ይሆን ነበር አይደል? እዚህ ጋር ይሆን ነበር አይሆንም? እዚህ ጋር ይሆን ነበር አይደል? that is what our expectation እዚህ ጋር ብቻ ነበር የሚሆነው ሜዠርመንቱ። ጌጁ ሪፒቴብል ቢሆን ኖሮ ማለት ነው እዚህ ጋር ነበር የሚሆነው። ኦኬ አሁንም እዚህ ጋር ነበር የሚሆነው። ይሄ የምንመለከተው ነገር the box, okay, the size of the box represents there is an issue of gauge repeatability. Okay, an issue of gauge repeatability. Now, once we study like this, once we study like that, then the next step is to look at like overall gauge study report. Okay, the crossed. So everything is okay, then I'm gonna say okay. So this is what I find. Okay, I'll tell you that. So let me copy that, copy as a picture, and now I'm gonna come here. So this is ANOVA, okay? ANOVA with interaction. Always just put with interaction. So now we're gonna interpret that. So it tells me this significant part-to-part variation. Significant. Okay, but here operator skill, they're all okay. I don't need just to teach them again. They're all trained. This is okay. Okay, part two operator variation or interaction is also okay. I'm okay with that. Repeatability, just like that, it's already just measured. So in this gauging system, all the problem is come from process variation. Okay, so in this gauging system, okay, all the problem is come from here. Oh God. Okay, all the problem are come from here, part-to-part variation, but the other is okay. Others are okay. Here is a problem. So ያ ማለት ነው ችግሩ ያለው ማኑፋክቸሪንግ ላይ ነው ያለው ማለት ነው። ችግሩ ያለው ማኑፋክቸሪንግ ላይ፣ ሌላ ቦታ ብዙ ችግር የለም ማለት ነው። this is without interaction። ይህንን ነው እናንተ ማንበብ የሚጠበቅባችሁ። this is only with interaction. Just forget about this. Then now when we come here, so it's going to just tell us like some information about like the gauging. Here you're going to do all these things. You see, total gauge render variation. Okay, total variation is how much? 43%. Okay, 43%. 43. So this 43 is what? Greater than 30%, isn't it? 30%. So I don't have a problem of reproducibility. Why? Because my operators are okay. You see, my operator skill set using that machine, they're okay. So the problem is on repeatability aspect. repeatability aspect. I already just mentioned for you right here. Okay, so here Ziga already ተረድቼዋለሁ ጉዳዩ። Okay, sicknessun already እዛ አውቀዋለሁ ምን እንደሆነ ችግሩ ከየት እየመጣ እንዳለ already ተረድቼዋለሁ። አሁን ምንድነው አንዷ ፓርት ነች እንግዲህ ሜጀር ስትደረግ አንዷ ፓርት ሜጀር ስትደረግ ምንድነው መሆን ያለበት ቲዮሬቲካሊ ምንድነው መሆን ያለበት ያቺ ፓርት በቃ ሚኖአቺ ከሆነች እዚህ ጋር ነው አይደል መቀመጥ ያለባት ላይክ ይሁላ ቫሪያንስ ማሳየት የለባትም አይደል ይሁላ ቫሪያንስ ማሳየት የለባትም አንዷ ፓርት you see all these variances that's what showed measurement በተቀያየረ ቁጥር part to part variation all these are like part to part variation which one is just measure precisely እዚህ ጋር precisely measure የተደረገው የትኛው ከፓርቶቹ which one is which part is measured precisely
Part 8.
these two the other is gonna show you lot of variables a lot of variables. Okay, so now okay the other is this is what we want now gauge evaluation this is gauge evaluation. So the difference between ይሄ ሁለቱ ቴብሎች ያሉት ዲፈረንሶች ምንድናቸው ይሄንኛው 6 ሲግማ ላይ ነው ይሄንኛው የመጀመሪያው ቅድም ያያችሁት 1 ሲግማ ላይ ነው 1 sigma line. The sigma level is 1, but right now the sigma level is 6. You see, 6. So at 6 sigma level, total gauge render ስንት ነው የመጣ የቀደሙ እዚህ ጋር ያሳየዋችሁ 1 sigma line, sigma level of 1. Okay, so draw. This is 1 sigma level. Sigma. Okay, level. That means what we are looking is 1 times the standard deviation margin. Okay, this is what we are looking. But most of like the industries are like what 6 sigma, isn't it? 6 sigma. Therefore, we are going to change that one 6 times the standard deviation. So this the one that I'm going to show you next is 6 standard deviation. You see, this one is when we evaluate the gauge, this is at 6 sigma. 6 sigma. Expecting like the process is operating at 6 sigma level. So the total gauge render here at 6 sigma. At 6 sigma, precision or error control rate, then our total gauge render is 65%, and this is greater than 30%. 30%. So our next step is to investigate where those errors come from. Okay, pictorial. We're going to look at those. Okay, so here, this is a report that were generated. Okay, so let me do this one, copy graph, and do like this. Like that. Then you see, this is where I've already just seen it. So this is operator, operator to operator variation. This one is operator to operator variation. Where okay, operator, and this is to look at like interaction. If there are like any cross, if one is gonna just cross for the other, there will be interaction, but no interaction here. No interaction. When we look at like the parts, this control chart, okay? Okay, this control chart showing this is with respect of like process accuracy, and this is with respect of process variance. So it seems like the process no issue with respect of like controlling the upper and the lower control limit, but the issue still is where is the spec? Where does the spec lie? That's the thing. So gauge R&R high, repeatability high, okay, reproducibility okay, no issue. Part-to-part variation, that's also high. So this issue is that come from more, you see, like repeatability is the same to part-to-part variation plus gauge error, that is error IJK, random error. That's what it is. But the part-to-part variation, you see, when we come here, where is the ANOVA? Yeah, ANOVA. This is with respect to the people. So when we see right here, what we understand is that the part-to-part variation is significant. So most of the repeatability issue is come from inconsistency of production, inconsistency or process deficiency or manufacturing variability. That is where it comes from. So, but this gauging information might not be just adequate, okay, adequate. አሁን በዚህ ተነስተን በቃ ጌጁ ችግር አለበት ብለን ኮንክሉድ ማድረግ እንችላለን ወይስ ደግሞ አንችልም የሚለው ነው የምናየው። አሁን ጌጅ ሪፒቴቢሊቲው ሃይ ሆኗል። ማሽኑ ነው ከፍ ያደረገው? ኖ ኢትስ ኖት ዘ ማሽን ኢት ኢዝ ዘ ፓርት ቱ ፓርት ቫሪዬሽን። ግልጽ ነው። ኢትስ ዘ ፓርት ቱ ፓርት ቫሪዬሽን and that is in production when we produce those parts because like they are highly precise products, the variation is come from the part to part. Okay, so now the next one, አሁን የነገርኳችሁ የጌጅ አር&አር ሪፖርት ትቀበሉታላችሁ ወይስ አትቀበሉት? ከባድ ጥያቄ ነው። አሁን ጌጅ አር&አር ዓላማው ምንድን ነው? ኦኬ ኦብጀክቲቭ ምንድን ነው? the objective is to check repeatability. Repeatability means gauge variation, gauge plus part-to-part variation, okay? Part-to-part variation, to assess that. So the gauge variation, whether the measurements are sufficient or the measurements are okay or not. Now, to determine the gauge variation, I'm going to show you here. I can do some more calculation. So I'm going to do like this. So these are like the parts. But how many parts I get? Like one is measure how many times? How many times? 3 times, isn't it? Yeah. 3 times. One is measure 3 times. So now let's take. Okay, just like that. This is part 1. Now we already assess that እነዚህ ኦፕሬተሮች ምን የላቸውም ብለናል፣ ዲፈረንስ የላቸውም ብለናል። We already got them. They use the gauge system, their capability is the same. So the variation is come from where? Here.
Part to part.
Isn't it? Yes, part to part. Therefore, what we're going to do is take this one by itself, take that, and go to another Excel sheet. I'm going to just paste it here, okay? Measurement. Now, I'm going to go to regression. No. T-test. Sample 1. Okay. So right here, I'm going to put like measurement. I'm going to put the measurement. Then I'm going to say, okay. You see? When one party is measured like 9 times by 3 operator, it's going to give you a mean of this and standard deviation of this, and the confidence interval is just like that. See, now I will show you what does it mean. Copy, and I'm going to put here only just paste as number. Good. This information is good. So I don't want those. What I want is, this is 1 sigma standard deviation, but 6 sigma equal to right here, this one times 6. Okay, this is a value. So it's going to just tell me lower 6 sigma value. This is going to be equal to the mean minus the lower specification, and upper 6 sigma value, and that's going to be equal to the mean plus this value. And here tolerance, okay, tolerance is the upper 6 sigma value minus the lower 6 sigma value. So what is this value? You see, okay, so let me format it. I don't know how I'm going to format it. Okay, format cells. Okay, not general number. And okay, I'm going to do it. You see, this is a value, tolerance. And now, what is the tolerance allowed for the gauge? The tolerance allowed for the gauge is this value. Okay, that's a gauge. So now we are going to compare which one is bigger, this one or this one. This is the tolerance allowed for the gauge. Okay, the gauge. So when you divide those things, this one minus by this one, you find this value. So which one is greater than tolerance of the gauge? Isn't it? Tolerance of the gauge is greater. So this is tolerance of the process variation and the measurement variation or repeatability. So because the gauge tolerance is greater than the tolerance itself, okay, the gauge tolerance at 6 sigma process, we conclude here no issue of the gauge, no issue with the, you see, this is our conclusion. እንዴት አድርጌ ያመጣሁት? ይሄንን እንዴት አድርጌ ያመጣሁት? ሚን ካልኩሌት አደረኩ፣ ስታንዳርድ ዲቪዬሽን ካልኩሌት አደረኩ፣ 6 times ስታንዳርድ ዲቪዬሽን አደረኩኝ። based upon that lower limit of the 6 sigma አገኘው፣ upper limit of the 6 sigma አገኘው። then upperውን ከሎወሩ ሳቀናንሰው this is the value that I get. that is the tolerance. አሁን ማሽኑ የሚሳሳተው ማለት እኮ ግልጽ ነው። ማሽኑ የሚሳሳተው ቶለራንስ በዚህ ቶለራንስ ውስጥ ነው። ያ ግን ከጌጅ ቶለራንሱ አይበልጥ በዚህም ያክል የጌጅ ቶለራንሱ ከማሽን ቫሪያንስ ቶለራንሱ ይበልጣል። በዚህ ጊዜ የጌጅ ችግር የለነበረም ማለት so the problem is I will copy this and put it here, okay, put it here. No gauging issue, gauge ችግር የለበትም። ስለዚህ all the problem is come from therefore Therefore, all the problem is come from what? Yes, part to part variation, because gauge variation only eliminate to do not la. The gauge variation is not as such significantly affecting my measurement. So case name at now, part to part variation. Part to part variation means when I produce them, when I produce the parts in the manufacturing area, so there will be an issue with there will be an issue that implies, okay, that implies, okay. Yeah, what does show you? That implies, yes, that implies process capability limitation. No, this shows there is, okay, process capability issue at the moment. Okay, the issue is, okay, process sheet. Okay, draw. Okay, this one. This is good. Okay, process. Okay, capability issue at the moment. Capability is the issue. You see, the issue. That's a problem. So that is, one is machine OEE. Okay, one aspect, appropriate usage of the machine. Second, machine capability. Third is machine preventive maintenance. Okay. Fourth, incoming material. Okay. Fifth, engineers, manufacturing engineers, you know, and so forth like that. Okay. So the አጠቃላይ ችግሩ ያለው የጌጂንግ ሲስተሙ ችግር ያለው የት ነው ማለት ነው? እዛ ሰፈር ነው ያለው ማለት ነው። But still our gauge report is not adequate. So let me show you here. We do gauge R&R. ያንን ስንሰራ ምንድን ያደረግነው? We already just feed information. We already just feed information. ምን አስገባንበት? ፓርት አስገባን፣ ኦፕሬተር አስገባን፣ ሜዠርመንት አስገባን። ኦኬ፣ ሜዠርመንት አስገባን። ኦኬ፣ ሜዠርመንት አስገባን። ሶ አሁን የቀረ እዚህ ጌጅ ውስጥ ያልከተትነው ነገር ምን አለ? እስቲ ምንድነው ኮንሲደር ያላደረግነው? Okay, so you should understand what you are doing here. So let me revise for you. Okay, let me revise what we are talking about. ምንድነው እያወራን ያለ ነው የሚለው ነው። Okay, so our equation is y equal to, okay, alpha target, that's mu, plus alpha I plus beta j plus error I j k now. So this is the measurement value, and we are trying to compare with the target. Target. When we say target, what we want to just measure. Okay, what we want to just measure. That's the target. So that is, this is what I call it, alpha I is the effect of like operator, and this is part to part. This is what we feed. This is all what we feed. Random error ምናምን ከተናል እዚህ ጋር ያልነገርነው ነገር ምንድነው ለዚህ
ምናልባት
ኢንቫይሮንመንት ምን
ሜጀር የምናደርግበት ኢንቫይሮንመንት ኢፌክት
ያ ላይክ እሱ ኮንትሮልድ ነው ብለን ብናስብ
ያህል ሜጀርመንታቸው ምን ያህል አልገለጽንም
ገልጸናል እንጂ እንዴት ነው ያልገለጽነው እሱንማ is already here ፓርቶ ስንቴ ነው የሚለካው እዚህ ጋር ፓርቶ 3 ጊዜ ፓርቶና አስቀምጠን አይደል is going to just tell you 3 times አንዱ ፓርት አንዱ ኦፕሬተር 3 ጊዜ ነው ሜጀር የሚያደርገው ያው እሱንማ አስቀምጠን ሌላ ያላረግነው ነገር አለ ምንድነው ያላረገው
የካሊብሬሽን ምናልባት
ቶለራንስ አልጨመርንም ነው የካሊብሬሽን ቶለራንስ ሳይሆን የጌጅ ቶለራንስ ኦርደር የስፔሲፊኬሽን ቶለራንስ አልጨመርንበት ግልጽ ነው here we miss specification ቶለራንስ አልጨመርንበትም ግልጽ ነው ቶለራንስ ፕሪሳይስ ነው ያለው ጌጁ እስከምን ድረስ ነው ፕሪሳይስ መሆንላችሁ የሚለውን ግን አልነገርነውም ማለት ነው ግልጽ ነው አልነገርነውም አይደል እዚህ ጋር ምንድነው ያንደር ቶለራንስ የሜዠርመንት ቶለራንሱን አመጣው ሪፒቴቢሊቲ ቶለራንስ ደግሞ እዚህ ጋር or I didn't tell this gauging system ሰዎች አሉ አርሴናል ምናምን እያዩ ምናምን ምን ይማራሉ አይደል እናንተ ናሎች to add the tolerance which here is your value you are going to put upper spec minus lower spec that is the tolerance this is what the value is okay the value then the value copy then we're gonna put here we're gonna go and here like this so we're gonna here ከቅድሙ የተሻለ ቁጥር አገኘ ቅድም ጌጂንግ ሲስተሙ በጣም በቃም የወረደ ነበር ይያልና ነበር የወረደ ነው በቃ የጌጂንግ ሲስተሙ በጣም ስለዚህ የትኛው ነው ኢንተርፕሬት የሚደረገው ይሄ ነው ይሄንኛው ነው ኢንተርፕሬት የሚደረገው ይሄን ነው የምናደርገው Yeah, ይህንን ነው የምናየው ማለት ነው። ይህንን ነው የምናየው እናነበው እዚህ ውስጥ ያለው ነው። So I don't have any reproducibility issue. Okay, repeatability is the issue, you see, but like most of the repeatability problem come from the part-to-part variation. 35.76% of the this repeatability problem. Okay, 35. Okay, አሁን አጠቃላይ እቺ ቁጥር እንደ ግራ እንዳታጋባችሁ ላሳያችሁ። Okay, copy. So I'm going to put here or here, just as number, paste like that. So I'm going to do it like that. Good job. Hello. የማሽኑ ችግርና ሲደመር ደግሞ ኖ ቢጫ ነው እንጂ ማረገው አረንጓዴ ማለት የማሽኑ ችግርና የፓርቱ ፓርት ችግር የፓርቱ ፓርት ችግር ምን ያህል ነው ፐርሰንት ኮንትሪቢዩት ስንት ሆኗል ማለት ነው 47 so 47 ይሄ 6 ጊዜ ስናደርገው ነው ኦኬ 6 times the standard deviation ይሄንን ያመጣል በ6 ጊዜ ኦኬ this is a column by the way ምን ማለት ነው a column ማለት let's say this is equal this one times 6 okay you see ይሄ ማለት ነው ሌላ ታሪክ a column ሲባዛ በ6 ይሄ ይመጣል ማለት 6 times standard then we're going to just normalize and calculate for what g error I mean percentage calculation. So when we calculate like the percentage is going to just fall to 31%, and this is greater than 30%. That is allowed. Okay, this is greater than 30%. Okay, so still the gauging system is acceptable. Acceptable. So what's going to be the next step? The next step is to work right here to adjust here. This is our opportunity. This is opportunity to improve. So this is assigned to operations plus MEs, manufacturing engineers, assigned to this MEs, manufacturing engineers, just like that. So this is going to be the action item. Action. So the engaging system ለማስተካከል እንደዛ ነው። ስለዚህ ሜጀር ኦኤሞች የሆኑ ለምሳሌ እነ ፎርድ እነ ኒሳን እነ ማዝዳ እነዚህ በአጠቃላይ ይሄንን ነው የሚጠይቋችሁ። እዚያውን ብትመጡ ጌጅ ስተዲ ነው አላችሁ የላችሁም ይጠይቃሉ። ስለዚህ it's one of the most important MSA. You see, one of the most important MSA is a case study. So operations plus MEs just to kill this part-to-part variation. Part-to-part. So is that okay or no? It's okay.
Okay. Yeah.
እንዴት ናችሁ? ደህና ናችሁ?
አለን
እንዴት ነው? ጌጅ ስተዲ ከዚህ በፊት ሰርታችሁ ታውቃላችሁ? ኤኒ ፐርሰን ከእናንተ ውስጥ ጌጅ አጥንቶ የሚያውቃለ? ዲሊት ዛሬ ጀምራችኋል ማለት ነው አይደል? ይሄ ዋን ይሄ ፒፕአፕ ላይ ፒፕአፕ a new product introduction. Okay, PPAP line one of the biggest document ስለዚህ ኦዲተር ሲመጣ ይሄንን ነው የሚያየው ጌጅ ስተዲ አለ የለም ነው if you do gauge study and if you are with respect for the requirements then they're going to just approve you otherwise they will not just they're going to hold you there okay so አሁን ምንድነው ፔሱ ትንሽ ፈጠን ይልባችኋል ዛሬ ወደ ማታ አካባቢ እንትን ልክላችኋለሁ ፕሮጀክት ማለት ነው ስለዚህ ይሄንን ኔክስት ዊክ ነው የምታስገቡት ማለት ነው ኔክስት ዊክ ነው የምታስገቡት እና አሁን ምንድነው የምታደርጉት እነዛ የመጀመሪያው ባች ከነሱ just request tutor maybe አሁን መተኛት የለም እኮ ከዚህ በኋላ ስለዚህ ቶሎ ቱቶር እነሱን ጠይቃችሁ ቶሎ ኮምፕሊት ማድረግ ነው ይሄንን ከዛ ሰሚት ኦኬ ስለዚህ እንደዛ ያረጋግን እንቀጥላለን እሺ so next week እንደዚህ አይነት አንድ ክላስ ደግመላችሁና ከዛ በኋላ attribute gauge ወይ ደግሞ ይሄ discrete gauge study ደግሞ እሱን አሳያችኋለሁ ማለት next week so you become like okay then okay this is MSA 2
okay
አሁን እንግዲህ ከዚህ በኋላ በደንብ ነው ስራው የሚቀጥለው አይደል እንዴ የኢትዮጵያ አየር መንገድ ሴንሰር የጎማ የአውሮፕላኖች ጎማ ሴንሰር ላይ ሲሰራ የነበረው ፕሮብሌሙ ምንድነው ማለት ነው የጌጅ ስተዲ ነው ማለት ነው አይደል ጌጅ ስተዲ ጌጁ አኩሬት ነው ወይስ ደግሞ አይደለም ጌጁ ፕሪሳይስ ነው ወይስ ደግሞ አይደለም ኦኬ ጌጅ ፕሪሲሽን repeatability እንዴት አድርጎ ያጠናል this is the way ስለዚህ ፊሽቦን ዲያግራሙ ላይ ጌጅ ስተዲ ካልከተተ ስፔሻሊ MSA ላይ ካልከተተ ፕሮብሌሙን አላወቀውም ማለት so that's what it is አሁን ጌጅ ሴንሰሩ በትክክል ዲቴክት ያደርጋል ወይስ ደግሞ አያደርግም that's what you are measure ስለዚህ you're going to just give bad pressure out of spec የሆነ እንሰጣውና ያን ዲቴክት ያደርጋል አያደርግም ስለዚህ ወደ አትሪቢዩት ሊሄድ ይችላል አትሪቢዩት ጌጅ አሬንደር ሊሆን ይችላል ግን ጌጅ ስተዲ ነው ኦኬ ግልጽ ነው
ግልጽ ነው ፕሮፌሰር
እና እሱን ካልከተትከው ያው የአየር መንገዱ ሰውዬ እንትን ሜዠርመንት ላይ እንደዛ መኖር አለ የሲቪሎችም እንደዛ አሁን ለምሳሌ የኮንክሪት ቼክ የምታደርግበት ብሬክ ቴስት እንትን ቼክ የምታደርግባቸው ማሽኖች ሪፒቴብል ናቸው አይደሉም ሪፒቴብል ካልሆኑ then you're going to just change it it doesn't tell you like the one that you are going to just intended for ስለዚህ እሱን በደንብ ማወቅ ያስፈልጋል okay so that's it for today ይሄ ነው ያለኝ እንግዲህ ጥያቄ ካላችሁ መጠየቅ ትችላላችሁ ግን ያሰብኩት ይሄን ሌላ ነገር አምጥቼ ፊድ ላደርጋችሁ አልችልም ይበቃችኋል ይቺን ከጠጣችሁ አይበቃችሁም
ይበቃል
እንዳይበዛ ሲበዛ ደግሞ ትንሽ እንትን ያደርጋል አይደል ስለዚህ እሱን ልክላችኋለሁ አሳይመንቱን አስገቡ ያንኛው አሳይመንት ሬዲ ሆኖ ይገባላችኋል ስለዚህ በዛ መሰረት እንቀጥላለን ማለት ነው እሺ እሺ ሰላም ሁኑ ቻው
Thank you. Okay, Professor. Thank you.
Bye. Thank you, bro.
Bye. Thank you, Professor.
Okay, thank you very much, guys.
Yes, thank you, Professor.
Okay, bye.
Thank you, Professor.